this is a worked example on how to do synthetic division of polynomial functions. So the first thing we want to do is set it up, and synthetic division has a much more interesting and easier to mess up setup than long division. So we want to be careful with what we're doing here. So what we want to do is we want to draw this L sort of shape, and I will use the nice straight line function on my computer here. You want to draw this big L shape, and then you're going to write the following values, and just follow along with me here. So the first thing we want to do is we want to identify what the zero of this term right here is. So actually, okay, this seems like something I can do in color, right? So the first thing we do is we identify the zero of this term. So I can set x minus 1 equal to 0, and I can solve to get x equals 1. You want to put this term in the top left corner of your synthetic division, and then you're going to put in order on the top row here the coefficients of this polynomial. So you can see that this term has a coefficient of 3. This term has a coefficient of -2, and then this term is a positive 1. So it would be 3, -2, 1. And so the very first thing you want to do in synthetic division is probably the easiest step, and you're just going to bring down this 3 into this bottom row. That's just the first step you're going to do. The next step is where it gets more interesting. You want to take this value of 3 and multiply it by the 0 we identified earlier. And so 3 times 1 is just going to equal a positive 3, and you can write that value underneath the next coefficient in the column next to the 3, right? Now what we do is we add along the columns, so 3 plus a -2 is 1, and then we're just going to repeat the entire process. So this 1 I can multiply by the 1 I identified as my 0. That is going to equal positive 1. Then again, we can add along the columns to find that 1 plus 1 is 2, and write that below the bar as well. Now, this is a completed synthetic division table, but we actually want to go through and identify or interpret what the table is saying. So it can be customary to write a little box or a separating bar on the last term you write down, because this term is actually going to be a remainder. So we can kind of separate it to show that it's separate, it's special, it's the remainder. As for these terms over here, these become the coefficients of the resulting polynomial from the division. So you want to think, we divided a degree 2 polynomial by a degree 1, right? Because this is degree 2, this is degree 1, you don't see anything there. And if I do that division, the resulting polynomial will have the degree it will have a degree equal to the subtraction of the previous degrees. That was a word mess. But what I'm trying to say is I can take the fact that the main polynomial is degree 2, I divided it by a degree 1, and 2 minus 1 is a degree 1. So I know my resulting term will be a linear, so it'll have at most degree 1. And then I can fill in the information about that polynomial using these coefficients. So this would become a 3x degree 1 plus 1 with remainder 2. And so that's how I've completed the division. That's how I interpreted the table. Now, as always, like we did in the long division example, we want to write this out in the form of px equals dx times qx plus rx. And so px is going to be the main polynomial that we were dividing. Dx is going to be the thing we divided by, so that's that term x minus 1. Q of x is going to be the answer we obtained from our division table, so I can write that as 3x plus 1, and then we simply add the remainder. Now, you can check if this is correct by expanding out this entire expression and seeing if it matches the left side, and you can verify that it indeed is equal. And you can also notice, if you watch the previous video on this worksheet, that we actually obtained the same exact answer with both long division and synthetic division. So both methods work equally as well. The one caveat of synthetic division that you have to be careful of is you can only divide linear terms. So that is very important. If this equation was different in the sense that, and I just went back a sheet, but if this equation was different in the sense that this had an x squared, I could no longer use synthetic division. I would need to use long division. Synthetic division depends on the fact that we were able to solve for a 0 like we did earlier. So that is a worked example on synthetic division.